This video talks about lesson 1-2, which is points, lines, and planes. So the purpose of this lesson is to understand basic terms and postulates of geometry. We will go through what postulates mean in terms of geometry. But to start, if you just take a look at this figure that we have here, it's essentially like a solid piece of board with an arrow going through it. And if you take a look at how the arrow goes through, it's like going up, and then it looks like it's going through here. So we want you to kind of think about this and think, can a solid piece of board have an arrow go up, through, and then back through over here in such a way? If you're at home and you're watching this, you can kind of pause and think about it. But in terms of us right now, we're going to answer that question, and you really can. And the reason why is in order for this to happen, the board, in a sense, would have to kind of bend to allow it to go back through. So your answer here is no, and you cannot bend the board. In order for that to actually be true and actually happen, the board itself would have to bend, and that's not going to happen. Okay. This is kind of like what we are going to be talking about today. We're going to think of boards or papers and then arrows. So like the board and the paper is going to be called something a plane, and then the arrows are going to be called lines. And we use arrows, pencils, things of that nature to help us kind of visualize the different postulates that we're going to talk about. Okay, so moving on, we have to go through some terms. And now this could be a little tricky. So before you kind of decide that undefined means something that you can't define it, kind of listen to this. So this statement says that undefined terms are basic terms that we use to build definitions of other figures in geometry. Okay, so basically, there are some terms that we called undefined terms. And it's true that those terms don't have a formal definition. What they have instead is a general description. Okay, so it's not something that has a definition, rather it has just a description. So they have general descriptions. So let's take a look at some of our undefined terms. And they're terms that you've been introduced to before. The first is a point. Okay, so a point we know really doesn't have any size. So whether I did a point that was this big or this big, they're both points. The pure purpose of a point is to indicate a location. So when you graphed last year back in algebra, you had a coordinate. That coordinate was a point. Its purpose was to tell you what is the coordinate. So is it 3, -2, 1, 1? It indicated a specific location. In geometry and in algebra, we name points the same way. You use a capital letter. So look over here, this diagram, we have a point, and this point is named A. Okay. So again, a point doesn't have a definition, rather we describe it. A point just indicates a location and has no size. Second undefined term is a line. So when you think of a line, I know when I think of line, I just think of something that extends infinitely in both directions. So here we kind of think of it as a straight path that has two opposite directions without end, right? So it extends infinitely in both directions. Along any line, there's infinite amount of points. So think of the number line. Again, last year in algebra, you used the number line, and you've only used a small piece of the number line. Maybe it was like -10 to +2. But very quickly, every number line we saw had arrows at the end, because even if it ended at -10, it continued to go downward, right? -11, -12, keep on going, and we approach infinity, negative infinity, actually, if we're going negative. So there are many points along any line. If you look over here in the diagram, we can name a line, right? We can name a line in a couple of ways. The first is any line can have a script lowercase letter. So here this has script L. So we can call this line L. Okay. You could also take any 2 points along the line, so A and B, put them together, and then put a little line with arrows above it. This is called symbol notation. So when we see AB with the line with arrows above it, we read that as line AB. If you flip the order and say BA, it's still correct because you're still associating along this line. You have to just make sure that the little hat on top has arrows at the end. There's a big difference if you leave off the arrows. If you leave off the arrows, it's actually called a segment. Okay, so we want to make sure that we're talking about a line by putting arrows. The arrows indicate that it goes infinitely in both directions. Okay, and the final undefined term that we deal with is a plane. And when I think of a plane, I actually I tend to close my eyes and think back to when I was in school and I was in social studies class, and they would talk about like the Great Plains. And when I think about the Great Plains, I just think about looking out and seeing green in all directions, just like fields and fields. That's kind of like a plane in geometry. It's a flat surface that just extends infinitely. It has no end. So a plane is a flat surface that extends without end. Just keeps on going and going and going. Again, a plane, kind of similar to a line, it contains infinite amount of lines. So in a plane, we have many lines that we can contain. In our class, I typically always use like a piece of paper to represent a plane. That's how I visualize planes. Um, but if you close your eyes, you could always think of the Great Plain. When they draw planes in geometry, it's like this parallelogram or this rhombus over here. It's like a square that gets kicked over. Typically, planes are drawn on an angle of some sort, and they always have points within them. Planes can be named a couple of ways. First, you'll always find a capital letter in a corner. So you see up here, there's this P, and the P doesn't have a dot with it. So I can name this plane P. I could not label it plane A. The reason being is that A is specific to a point, where P is just up in the corner. So one way is with a capital letter, plane P. Okay. Another way is by using 3 points in the plane, but they can't be 3 points that are on the same line. So if you take a look here, A, B, and C, here are 3 points, right? These 3 points, I could never draw one line for them all to be on. So I can call this plane A, B, C. That would be fine. I could also call it plane C, A, B. You need at least 3 points, though. At least 3. You can't just put 2. It has to be at least 3 points. Remember, at least means 3 or more, essentially. Okay, so now we have point, line, and plane, all undefined terms. We described them, and we saw how to name them, as well as a diagram that represents them. Okay, so now we're going to move on, and we're going to talk about points that are collinear. And one thing that we do in this course is we break apart terms. So we have co and then linear. And within linear, I'm hoping that you see the term line. And if you think about think of like co-teachers or co-captains. They're captains that work together. Co-teachers are teachers that work together. Like they have a common goal. They're doing the same thing. So points that are coplanar simply means that they're points that lie on the same line. So we're going to put here, same line. Okay, and here we have it. So if I were to put, do like 1, 2, 3. Draw a line quickly. Okay, so green, yellow, and purple dot are all collinear, excuse me. And the reason why they're collinear is because they're all along the same line. As soon as one pops off, now they don't become collinear. They're called non-collinear points. So collinear, they're all on the same line. Okay. Now, similarly, we have something called coplanar. That's when you have points and lines that are in the same plane. So when they're on the same line, they're collinear. When they're in the same plane, they're called coplanar. So if you just like look to the right over here, we have a line RS, and then we have this point V. So RS, line RS, and point V are coplanar. They're in the same plane. They're both in plane P. All right, so now let's try to use some of this terminology and see what we can figure out. So we're going to use this diagram to the right, and we're going to try question A. What are two other ways to name QT, and then there's a symbol over it. So this means line QT. That's how you name it. That's how you read that. So that's line QT. So that symbol represents line, and then we have QT. So we're focusing on, right now, line QT over here. We'll crook it out like that. So we're going to go down the line QT. So think about how we name a line. You name a line by using 2 points on that line or by using a lowercase letter. So if I take a look here, I have QT, so 2 points on QT. I could actually also name it TQ, so line TQ. I could even say line NQ. So I'm going to put here, I'm going to stick with, how about I do NQ? NQ, but I have to add an arrow on top. So arrow up this, and it has to be an arrow both ways. So make sure you have an arrow on both sides, just like that. And then the other way is I'm going to use this lowercase letter right here, and I'm going to call this now line M. There you go. So we use 2 points on the line, and then Q, and then we also use the lowercase letter line M. Right, B. What are two other ways to name plane P? Okay, so we use the uppercase letter P, that's one way. The other way is to pick 3 points that do not lie on the same line. So 3 points that are non-collinear. So you can see some points, and I'm going to pick out this point here. I see V. So I have point V. And then maybe I'll pick point S. And then I'll pick point R. So V, R, and S. No one line can contain all 3 of those points, so that's a good way to name that plane. So we're going to write here, plane RVS. You do VRS as well. Another way to name that plane. All right, so now let's maybe go with, we'll pick Q. I want to change the color. Pick Q. We'll pick V. And how about R? So we could pick plane Q, V, R. What we cannot pick is plane R, Q, S. Let's put that here. Not plane R, Q, S. And the reason being is because R, Q, and S are all on this line L, so that's not okay. The 3 points that you pick have to be non-collinear points. Okay. Now here it says, what are the names of 3 collinear points? Oh, well, that's kind of nice, right? The 3 points that are collinear, the 3 points that are on the same line are R, Q, and S. So points R, Q, and S. Collinear. They are on the same line. What are the names of 4 coplanar points? So just the 4 points on the plane. So on this big yellow plane, we have points S, Q, R, and V. So points R, Q, S, and V are coplanar. And there we have it. So that was practice. with using terminology like coplanar, collinear, naming lines, naming planes. Now let's go down here and use the same diagram and see if you can try these questions. I want you to try to pause and answer these questions by yourself, and then unpause and you can listen to me go through the answers. Okay, so first, what are two other ways to name RS? So we're talking about line RS, which is right here. And let's go through the two ways to name line RS. So the first is we could simply call it line L, right? Because there's that lowercase l, so we can call it line L. We can also use R and Q to name RS. So I can do RQ. Think about what we did before. You have to put the little symbol above it. This is a line, so we need to have the arrow on both sides. So here we have this. Put my arrow. Perfect. To RQ. And feel free to also do something like QS. If you have RQ, you can do QS. There's a number of different things. We only need two, so I'm going to stick to just these two. Okay, what are two more ways to name plane P? Okay, remember, a plane has to have three letters that are non-collinear. So we can say, how about plane RVS? RVS are not collinear. So that's a good way to name the plane. Another way is we can do plane, how about we did like QSV? There are other options, but these are the two that I kind of see. RVS, QSV. You can do SVQ, QVR, number of different ways. All right, C. What are the names of three other collinear points? So you have points, I think we said was R, Q, and S. We want three other collinear points. So besides R, Q, and S, what are the three other collinear points? So where's my other line? So for that, I have this line. The other line I had was line M. So your other three collinear points would be points N, Q, and T. And it says, what are two points that are not coplanar with R, S, and V? Okay, so let's see where R, S, and V are. So we have R, S, and V. They're on this yellow plane, plane P. What two points are not on that plane? So what two points are not coplanar? And that would be points N and T. Cool. Right. So here we kind of completed a practice of using the terms coplanar, collinear, naming lines, naming planes, finding points, things of that nature. Okay, so let's move on now to some defined terms. So here are some defined terms. First is a segment. A segment is just a piece or a part of a line. Most importantly, it has two endpoints. Segments can be measured. So a segment is like a start and an end, you can measure it, whereas the line goes on infinitely in both directions, so you cannot. What's nice about a segment is there's really only one way to name a segment, and that's by using the two endpoints. So you look at the segment, you look at the endpoint, the two capital letters on the end in either direction represent the segment, and above it is just that line without arrows. That shows that it's segment AB. So segments is a part of a line, can be measured because it has endpoints. Those two endpoints name the segment with a little bar on top of it. Okay, then we have something called a ray. And for a ray, I like to think of like a sun ray. And again, it's a part of a line, but the difference is it only has one endpoint, and then it goes on infinitely in the other direction. So a ray cannot be measured because it extends infinitely in one direction. A ray is like an arrow. So if you look over here, you have one endpoint, and then you keep on going, and you show you keep on going by putting on an arrow at the end. That's a ray. Now, array is named very specifically. The order matters. This can't be named ray B, A because it goes through B and extends infinitely. So you start with the endpoint, and then you go to another point towards that arrow. So ray AB is how you would read this. The notation is like an arrow on top. So it's endpoint, and then the point it goes through with the arrow facing in that direction. The order of the point indicates the ray's direction. Okay, so that's really, really important. And then finally, when you put two rays together, right? So it looks like here I have two rays that are put together, and they share an endpoint. They're called opposite rays. So opposite rays are two rays that share the same endpoint. Opposite rays form a line. Okay, and it says here you can name opposite rays by their shared endpoint and any other point on each ray. So notice how these two rays, they're opposite rays, and they both start at endpoint C, and then they go in opposite directions. So they go in opposite directions, they form a straight line, they share the same endpoint. All right, so let's go through then how to name some of the segments in the figure over here. Okay, so remember, we're naming segments, so that's going to have the bar on top. So the segments over here. So some segments that you see. I'm going to highlight one segment that I see, and the first segment that I see is this segment right here. So how would I name that yellow segment? And I would name that segment by using the endpoints, D, E. But it needs to have a little hat, and since it's a segment, it's just a bar, like that. Remember, that segment can also be named ED, right? Because it's just from one endpoint to the other, and it needs its little bar. So there's one. Another segment that I see is from here to here, and I would name that segment using the endpoints E and F. So you have EF. And we need a little bar, so there's a little bar. Okay. It could also be called FE, right? Because again, just need the endpoint. Excellent. So we have FE now. And then another segment, how about if you went all the way from D to F? That's a segment. So you have segment DF. Or if you flip it around, it would be FD. This is just a nice little nice use of using the same two letters in opposite order to name a segment. And for right now, that's great. So we have three segments right there. One, two, and then the third. Okay, how about some rays in the picture? So some of the rays. So remember, a ray needs an endpoint and then needs to go infinitely in one direction. So I can't say ray D because there's no other point. So I'm going to have to start with ray with point E. So let's start with point E. So I could have ray EF. I could go from E through F. So I'm going to write EF. I'll put my little arrow. That works. Okay. I can say ray ED. I could go the opposite way. Put here ED and my little arrow. Okay, and then that's really it for E. Of EF, ED. F can't go this way. Oh, but F can go this way. So I could say ray FE, right? FE. And actually, FE could be FD as well. Represent the same thing. Right? Because both of them start at F and go in the direction towards E and then towards D. So they represent the same thing. It's just two different ways to name the same ray. And then finally, I mean, I could actually start at D, and although I can't go in this direction to the left, I could go towards the right. And I can name it then DE or DF. Perfect. And there are 4 different rays in this diagram. Perfect. All right, now let's go to C. Which of the rays in part B are opposite rays? So look at what we have here. So we're going to look at part B, and which ones are opposite rays? Remember, if they're opposite rays, look up here. If they're opposite rays, they have to share the same endpoint. So they have to start at the same endpoint. So let's take a look here. Which starts at the same endpoint? Oh, and actually, we have it right here, right? EF and ED. So take a look at EF and then ED. They both start at E and go through F. This goes at E, it goes through D, and they form a straight line. So we have both ED and EF, and the reason they share endpoint E and go in opposite directions. Just let's make sure that we put our little ray symbol on top of ED and EF. Perfect. All right, now let's go to the got it question. It wants to know, is EF, so EF and FE, do they form a line? Oh, it says EF and FE form a line, excuse me. But are they opposite rays? And explain. So let's go back up here, and I'm going to erase what we have. Okay, so you have EF. I'm going to take my arrow. I'm just going to go like from E to F, there. And then you have from F to E, there. So they form a line, certainly. But are they opposite rays? So just because 2 rays form a line, do they make it opposite rays? And in this case, we talked about having opposite rays. So ask yourself, EF and FE, do they share the same endpoint? And look up here. The endpoint here is at E. The endpoint here is at F. So are they opposite rays? Now it's kind of easy to answer. The answer is no. They do not share the same endpoint. Okay? So this lesson is a little long, so we're going to stop this lesson here. So you listen to the first half of lesson 1-2, which is points, lines, and planes. And tomorrow we're going to have you listen to the rest of lesson 1-2.